Hello, welcome back to our lectures about Java object-oriented programming and data structures. So today we will discuss chapter 17, so regarding sorting. And you can find our textbook on Kendall Hunt publisher. The sorting algorithm we will discuss in this chapter include bubble sort, selection sort, insertion sort, share sort, quick sort, and merge sort. So we will start with bubble sort. Bubble sort, there is another name called exchange sort. And generally, when we do bubble sort, we use iterative approach. So bubble sort is also considered as an iterative algorithms. What it does is going to traverse a list of unsorted, okay, and elements. The unsorted element can be arranged in array or some other data structures. And what it does, it will compare adjacent pairs of elements and swap them if they are out of order. So this is a key part in the process, okay? And the process will continue until no further swaps is needed. Then in that case, then that indicate the list is already sorted. So this is a general idea about bubble sort. Okay. Regarding about the implementation of bubble sort, it needs a nested loop structure. So the outer loop will run as long as swap are needed. Okay, so if there is no swap needed, then basically the algorithm terminates. Okay. What the inner loop does is iterate through the unsorted portion of the list and does the comparison and swap. So that's the implementation. It needs nested loop structure, okay? And why we name it as bubble sort? And the idea is because within each iteration of the outer loop, okay, then the largest element in the working sublist, it will sync to the correct position at the end. So basically, the largest element for that unsorted sublist. So largest element in the unsorted sorted sublist will sync to the correct position. Basically, over here, it's the end of sublist. So the sublist, the size basically is shrinking, okay, for each iteration of the outer loop. So it says after each pass, basically the largest element is sorted. So the largest will be put at its correct position, like over here says. It's at the end of sublist, but it overall for the whole list, it's the right position, okay? And then it will be excluded from the further comparison for the next iteration for the outer loop, okay? And the process will repeat until only one element remains in the inner loop, okay? Then in which case the list is fully sorted. So, but if there is no swap needed, then the list is also sorted. Okay, so that's not always that it will end at there is only one element in the inner loop. Okay. So next, let's take a look how we use bubble sort to uh, do the sorting for this list. This is a very simple, and the list is not long, okay? So the original list is like this. So what the whole bubble sort, the idea is the outer loop. For the outer loop, the first iteration, what is supposed to have is you have an unsorted sublist. And then the largest element, obvious, here is 87, is it? And then 87 will be moved. Okay, so basically we will say it will be swapped to the end. So this is the first iteration. Okay, then the second iteration for the outer loop, then then for the next iterations, 87, you don't need to sort. So you will only do compare and swap for the unsorted sublist. Okay, so then it will be shrink again. So in this case, we can clearly see 979 will be in the its right position. So now 79, 87 sorted. And then the sublist is unsorted. But that depends, okay? It may not always be true, okay? Sometimes we will also see that it may be sorted, okay? So if sorted, how do we know if it's sorted? It's indicated by no swap. When we do comparison for the inner loop, if no swap, then it means it's sorted. If it's sorted, then the algorithm ends. So that means the whole list is sorted. Okay, so that's the idea. So let's take a look. Okay, so the first, so right now we are doing the outer loop. The first iteration is goal is to move 87 to the end. So how do we do it? So then we move to the inner loop. What the inner loop does is it does the comparison between the two pair of numbers. Okay, and in this case, it's not sorted, so we are going to swap. So we move 35 to the first and 67 to the next. Okay, then we compare the next pair. Okay, it's not so 69 greater than 18, is it? So we need to do swap. So 18 here and then 69. And then you compare the next pair. The next pair, it's already, so 69 is already less than 87. So no swap needed. Okay. So you move on to the next pair. And for this pair, okay, 87 is greater than 50. So we need a swap. So 50 and then 87. Okay, and then we continue compare with the next pair. So clearly 58 is less than, so we do need a swap. So 58 and 87. Okay. And then we continue for the next pair. Okay. Then clearly 87 is greater than 79. So we do need to swap. So 79 and 87. Okay. So so this is the first iteration for the out loop. Okay, so after that, we can see the original list change it to 35, 18, then 69, then 50, then 58, then 79. Okay, then 87. So 87 does moved to the end, at the end of the first iteration. Okay. So then starting for the second iteration, we will only do this compare and swap for this unsorted sublist because this one is already sorted. Okay, and this is unsorted. So we are going to do the compare and swap. Okay, so let's start again. So we compare this pair, and clearly we do need a swap. So 18 and 35. And then we compare the next pair. Okay, it's already in order, so no swap needed. And then we compare the next pair. Okay, we do need a swap. So 50 and then 69. And then we compare the next pair. Okay, we do need a swap. So 58 and 69. And then we compare the next pair. Okay, there is no swap needed, is it? And at the end of the second iteration, we see, okay, 79 does. So it is placed at the end of this sublist. So at the end of the second iteration, our list looks like this. So 18, 35, 50, 58, 69. And then we have 79 and 87. And we can clearly see these two already sorted. And for this sublist, it's unsorted. Okay, so then we will start with the third iteration. Okay, for the third iteration, so let's do it again. Okay. So we do pair by pair comparison and to see if the swap is needed. So no swap needed, no swap needed, no swap needed, and no swap needed. So we can see for this sublist, there is no swap needed. So that means all of the items are already in their correct position. Is it? So that means it's already sorted. And because this sublist we checked, it is sorted. Is it? And the last two items are also in their correct position. So now we can clearly see this whole list is sorted, okay? And for this algorithm, then we don't need it to, because no swap needed, it's already sorted. No swapping in this iteration, so that means the algorithm, so sorting terminates. So sorting ends. And the whole list is sorted. Okay, so this is how bubble sort, or another name is called exchange sort, works. And we can clearly see why we call exchange. Is it because we do comparison, and then if the swap needed, we exchange the two items. Okay, so that's the general idea about bubble sort. And in our textbook, we also implement bubble sort, and the way we implement, we using array. Okay, and you can refer our textbook for the bubble sort function implemented using array. Okay, so that's the discussion about bubble sort. So let us stop here, and we will come back for the next sorting algorithm.